Hello, we are in Chapter 6, Section 6.4, Equations Quadratic in Form. In this video, we're going to go over problem number 1, in which we are to solve this equation using U substitution. So when we talk about U substitution and equations quadratic in form, we are trying to find the building block that is once in the first and once in the second power in our equation. It looks like that building block in this equation is what we have inside of the parentheses, negative 5x minus 2, because it's once in the power of 1 in here, and then in the power of 2 in there. So we will let u be equal to the content of that building block. So we will let u be equal to negative 5x minus 2. And that's our translation dictionary, as we can call it. We are replacing so far every instance of negative 5x minus 2 with u. So we're gonna get 15u squared plus 4u minus 4 equals 0. This is a quadratic equation that we solve for u. Let's check quickly if it is factorable. 15 times negative 4 is negative 60, so we try to present the number negative 60 as the product of two numbers that add to 4. It appears that negative 6 and 10 will do it. They multiply to negative 60 and they add to 4. So we can split our middle term into minus 6u plus 10u. And rewrite the rest, 15u squared and minus 4 equals 0. And then finish with factoring by grouping. So in the first group, we have a common factor of 3u. And after factoring it out, we are left with 5u minus 2. So for grouping to be successful in the second group, we also need a factor of 5u minus 2. And we can achieve that by factoring out 2. Still equals 0, and now a common factor of 5u minus 2 is factored out, leaving us with the factor of 3u plus 2 equals 0, and we are now ready to use the 0 factor property. It's either 5u minus 2 equals 0 or 3u plus 2 equals 0. So after adding 2 to both sides of the first equation, we get 5u equals 2. And after dividing both sides by 5, we get u equals 2/5. While in the other one, after subtracting 2 from both sides, we get 3u equals negative 2. And after dividing now both sides by 3, we get u equals negative 2/3. Now, these are our u solutions, not the x solutions, so we need to translate back into the x language. So every instant of u in the statement of the u solutions will be replaced by u is negative 5x minus 2. So we're going to have negative 5x minus 2 equals 2/5. Or negative 5x minus 2 equals negative 2/3. Now these equations must be solved for x to obtain the solutions to our original equation. In the first one, we can start with adding 2 to both sides. So on the other side, it's better to write it as plus 10/5. And we're going to get negative 5x equals 12/5. And then we divide both sides by negative 5, or in other words, multiply by negative 1/5. So we can write like this here, and we can write it like that on the other side. So it will be easier to multiply the fractions. So we get x equals negative 12/25. And then in the second equation, we also start with adding 2 to both sides, presenting 2 now as 6/3 on the right-hand side. That leads to negative 5x equals 4/3. And then again, we divide both sides by negative 5, or in other words, multiply by negative 1/5. So that will give us x equals negative 4/15. And those numbers cannot be further simplified. So with the word or between them, these are actually the solutions of the original equation. I encourage you to plug them in and check, just to make sure.